What's up, gamers? I'm Michael Miller, and today we're going to learn about the wondrous world of watts and power. So, in order to do this, we're going to have to do several different things, including go look at my circuit breaker, measure the different watts on different appliances I have, and also we have to go to that spinny thing on the side of my house. But before we get to that,
Want to join my free gift card giveaway? Subscribe to my channel, like the video, and turn notifications on.
Alright, now that the jokes are over with, we're going to have to start by learning what watts are. So watts are a unit of power that measure the rate at which electricity flows through something. So here we have is two chargers. We have the charger from my Chromebook, which we can see here has a max of 45 watts. And on my laptop charger, it says it has a max of 130 watts. This is due to the reason that the Chromebook is a smaller unit than my laptop, therefore it needs less electricity. So this doesn't have to pump out as much electricity or transfer it as fast as this one does. If we were to go downstairs, we would also see my refrigerator, which does a lot more, and we will be going down there in a second. So yeah, so basically, this one transfers more because the laptop's a bigger unit and needs more electricity to be charged and stuff than this one does because the Chromebook is smaller. Now let's go downstairs. Alright, now that we're downstairs, pardon the dryer by the way, we are here at my refrigerator. Before we go into the watts, let's take a moment to admire my beautiful art when I was a child. Okay, now let's get into the refrigerator and watts. So, we can assume this uses around 1,000 watts an hour, but we can't exactly check because it says somewhere on the back of the refrigerator, and it's kind of a lot of stuff in the way. Okay, so this uses a lot more because obviously it's a bigger unit, and this also has to be running constantly to keep all the food inside cold, rather than the chargers upstairs that don't have to use as much. They only have to charge it up to full. So yeah, this uses a lot more because it's bigger, and then it's also constantly has to be running to keep my beautiful garlic stuff cold. Alright, so now let's go visit the circuit breaker and see what's up with that. Okay, so here we are in the garage where we have one of our two circuit breakers in the house. As we can see, for the most part, majority of them are labeled. We have for the dryer, the furnace, the freezer. These ones aren't really labeled. We have for the garage where we're in now, it's just the one we're going to test on. We have the kitchen lights with the dishwasher, and we have our pool. We're going to test the garage one for now. We're not going to test these two because my mom's working up there right now and she'll get really mad at me. So, and obviously the pool's not open yet. So as we can see, if we flick this one off, the lights in the garage go out. Don't mind all this stuff. My dad has a lot of stuff. And if we flick the switch back on, the lights go back on. So as we can see, the switches on the circuit breaker successfully switch off the things they're supposed to. So yeah, I'll see you at the next part. Alright, here we are outside. It's kind of drizzling, but that's okay. As we can see right here, we have our watt meter, and it measures in kilowatts per hour. You probably can't see, but it says like somewhere right there, kilowatts per hour next to that number. It's kind of fogged, so you can't see. It says like, is it 55,000? Yeah, so our house is making a lot of kilowatts an hour. So if we, theoretically, if we were to turn off everything inside, this should go down a lot, and vice versa. If we turn on everything inside, it would go up a lot. But one, I'm not gonna be able to turn everything down because my parents are kind of working inside, and they'll get very mad if I turn everything off. And two, my dad is very conservative about electricity. If I was to turn on everything, that would cost him a lot, and he would get mad. So we can see that we have it here. It shows how much the house is using an hour, and if we were to turn off everything, it would go down. If we turned on everything, it would go up. So yeah, I'll see you back in my room for the next part. For my wild card, I'm going to be doing why some wires have 3 prongs, while others have 2. So the reason behind this is that some wires typically have to transfer more energy than others, those being ones with higher watt values, and these ones typically have to have the 3 prongs. This is because this third prong is a ground, which means that it keeps the circuit from spiking or overloading, and it also keeps the unit from being burned out. So, and this one doesn't have it because this doesn't have to transfer as much energy. It transfers a little amount just to charge your phone, while this one has to transfer a lot to charge a whole laptop battery. So yeah, that's why some have 3 while others have 2. It's just to protect the circuit from blowing out due to high amounts of energy. So that's about going to wrap it up for now, guys. If you guys like this physics video about the wondrous world of watts, make sure you like, comment, subscribe for more physics videos. And shout out to my father for helping me find where the circuit box was and trusting me to not break his garage. And I will see you guys next time.